So let's start with number 1. Okay. So for number 1, I think
It's
this one.
number 172 meters.
Again. Yeah, it's
72.
okay. That's 72. You are correct with that one. So no need to explain number 1. Number 2,
Number 2, is it 36.2?
30. Wait lang. I'll check it. 7.24 times 3.6 plus 2.8 times 3.62. It's 36.2. Yes, you are correct. For number 3,
Is it 501,000?
yes, correct. So, do you know how to do this one naman, no?
Yeah.
Okay, so no problem with that one. Number 4, do you know how to do number 4?
Is it 31?
It's wait lang. Hmm. Okay, so number 4, yes, it's 31. Okay, then how about number 5? Do you know how to do number 5?
Number 510?
Yes, so no questions about this one, no?
No, none.
Okay. Number
6, is it C?
Yes, it's letter C, correct. Number 7.
And I didn't answer none the rest of it.
Okay, so for number 7, so this one is the one my teacher told me when I was in college that there are, remember this one, this is very important. When dealing with prime numbers, there are 25 prime numbers below. Okay, 25 prime numbers. So I'll just write P. Okay, 25 prime numbers below 100. So what you're going to do now is, since we are only asking for the two-digit prime numbers, so how many are single-digit prime numbers? 2, 3, 5, 7. So there are 4 single-digit prime numbers. So since we're asking for the two-digit prime numbers, 25 minus 4 is equal to 21. So that's how we do number 7.
Wait, how again?
Okay, so again, um, you can list all prime numbers from 1 to 100. You can do that one. Pero it's very helpful to know that there are 25 prime numbers below 100. So again, there are 25 prime numbers below 100. No? And how many out of okay, out of those 25 prime numbers, 4 of them are one digit number. What are the one digit prime numbers? I mean, one digit prime numbers: 2, 3, 5, and 7 only. So just simply remove these 4 out of the 25 prime numbers below 100 and you will get 21.
Yeah.
Okay? Is number 7 clear?
Yeah.
Okay. Next one, number 8. So number 8. Okay. Do you have an answer on number 8?
I didn't answer the rest of it after 6.
Okay. So okay. So for number 8, actually what we can do here is just simply write the what is this? Simply write the
Wait, I'm not sure, but is it wait, never mind.
okay. So what you can do here is write it as what do this use the LCM. The LCM for, or the LCD here is 128. So 1 is actually equal to 128 over 128. Okay, and then 1/2 is just simply 64 over 128. And then 1/4 is, what is 1/4 again? 32. 32 over 128. 1/8 is 16 over 128. And then 1 over 32 is 8 over 128. And then 1 over 64 is 4 over 128. Whoa, wait. 128, 1 half is 64 over, and then this is 32 over 128. 1 over 8 is, I'll check 1 over 8 is, I think that is, yeah, I'm correct. And then 1 over 32. 1 over 32. Wait lang. 16 over 128, correct. And then 8 over 128, that is 1 over 16. 4 over 128 is 1 over 32. Okay. Minus 1 over 64 is 2 over 128. And then minus 128. And then since we already wrote everything, or we wrote the sentence in similar fractions, you can just simply do the operation 128 minus 64 minus 32 minus 16 minus 8 minus 4 minus 2 minus 1. So doing that one, and that is an easy task, the answer will be 1 over 128.
Oh, I was gonna say that, but I wasn't sure.
Okay,
Like the
so
one over 128.
okay. So let's move on to number 9. So for number 9, there's nothing, well, wait lang I'll look for a pattern here. Kasi you can just simply multiply those numbers, right? 256 times 4. It's not. Okay. So yeah, just to save time, you can just simply multiply those three numbers. Okay.
Yeah.
Oh, so nothing fascinating about number 9, nothing so difficult about
Nothing.
number 9. Yeah.
I think I
Number
can do 10.
yeah,
Yeah, that's
same.
just easy.
Yeah. So let us
It's
skip those.
easy.
Correct.
Okay,
Okay.
then. Yeah.
Let's move on to number 11. Number 11, this is very common to the when it comes to our reviews on the past few days, right? Flight of stairs.
Yeah.
So are you familiar with this one, or you're not yet familiar with doing number 11?
I'm familiar, but
O sige, I'll explain
well,
it pa
it's
rin.
confusing. It's confusing.
Okay, so I explain it again. So it's either one step or two steps, right? So first, I'll start with all of them are one step. So I can do 11 single step, 0 double steps. Correct?
Oh, wait. I think I remember now. But the ones that are confusing is the one with
With the one broken, with the one that is
yeah,
but
yeah.
this one is not broken, so it's okay naman. Okay?
Mm.
Next. So isn't it that on the past review, what we do is
But
11.
usually it's broken kasi.
Okay. Sige. 'Di ba on the past reviews, what I am doing is I'm just going to write 11, 10, 9, 8, 7, 6, 5 up to 0. And then here it depends, right? In here, we cannot use 10, we cannot use 8. Why? 10 single steps, 10 single steps plus, we cannot do 2 steps anymore kasi the sum must be equal to 11. 10 single steps plus 1 double step is not 11. So we cannot use the even numbers here. So what we're going to do here is we're just going to use an odd number for the single steps. So in that case, 11 single step, he can have, or the person can have 9 single step, 9, 7, 5, 3, 1. And then here for the double steps, even numbers. So 0 double steps. So in this case, 1 times 2, so 1 double steps. So in this case, 2 double step. In here, 3 double step. In here, 4 double step. And then in here, 5 double step. You might be confused about this one. 11, kasi this will be, this will be 11 times 1. So it means that the numbers here are multiplied by 1. The numbers here are multiplied by 2. So if you do that, this all of this must be equivalent to 11. Let us check first, okay? So that you will be I'm convinced. 11 times 1 is 11 plus this is equivalent to 0. So in that case, that is 11. 9 times 1 is 9 plus 1 times 2 is 2. So in that case, that is also 11. 7 times 1 is 7. 2 times 2 is 4. So I think you're getting the pattern here. No? Next, let us now focus on the solution itself. Oops, let me erase the green ones. Okay. So how do we do this one again? We're going to use a factorial. So first, add these two. You add the two numbers, that will be your numerator. That will be 11 factorial. On the second number, sige, let me do it one by one. 11 factorial over. You get the factorial of this and then this one. So this will be 11 factorial. Oops, this will 11 factorial times 0 factorial. Solving for this one, this is just simply equal to 1. Next, for this one, add this two. 9 and 1, that is 10 factorial over, get the factorial of each number. 9 factorial times 1 factorial. 9 factorial times 1 factorial. So solving for that one, that is equivalent to 10. This one naman, add this two. 7 plus 2 is 9 factorial. And then that will be your numerator. And then for your denominator, get the factorial of each number. 7 factorial times 2 factorial. Okay, so 7 factorial times 2 factorial. So solving for this one will be 36. Next, same thing with this one. Add this 2, and that will be your numerator. 5 plus 3 is 8. So we will now have 8 factorial divided by the factorial of each number. So your denominator now will be 5 factorial times 3 factorial. So I'm just going to write it here. 5 factorial times 3 factorial. So in that case, if you manipulate that one, we will get here 56. Add these two for the second to the last. 3 plus 4 is 7. So that will be 7 factorial over. Get the factorial of each number. So that will be 3 factorial times 4 factorial. So 3 factorial times 4 factorial. So in that case, yan. So in that case, that will be equivalent to 35. And then, for the last item, what you're going to do is just simply add this two again. So that would be 6 factorial over the factorial of each number. 1 factorial times 5 factorial. So 1 factorial times 5 factorial. So in that case, if you solve that one, you will get 6. The last step is just simply add these numbers. 1 plus 10 plus 36 plus 56 plus 35 plus 6. What will be the sum? The sum now will be, wait lang the sum will be equivalent to, what number is this? This is number 11, 144. So that is the answer for number 11. Okay? So this type of question is very common to this type of competition. No, in MTOP it's not common, but in this type of competition that is under the Math Olympiad, well, this is very common. So I am hoping that you already master this type of question.
Yeah.
Okay, thank you. Next one. So I'm going to clear this one. Next is this one, number 12. Okay, so number 12, find the value of that one. So I think you can do this one. This one is equivalent to 3.5, or that is 7 over 2. So in that case, this one, the one that I'm going to encircle, color green, this will be now equivalent to 4 plus 2 over 7, correct? Next, 4
Yeah.
plus, yes, 4 plus 2 over 7. And I'm just going to use my calculator. 4 plus 2 over 7. So that will be 30 over 7. Okay, so the equivalent of this is 30 over 7. Now, if that is 30 over 7, therefore, this one, the one that I'm going to encircle using the blue ink, this one will be now equivalent to 3 plus 7 over 30. Correct? So 3 plus 7 over 30, and that will be equivalent to 97 over 30. So this is 97 over 30. Meaning, the one that I'm going to encircle using a purple ink. So this one now, okay, is equivalent to 2 plus 30 over 97. So you can just simply add those two numbers. So 2 plus 30 over 97. So the answer now will be equivalent to 224 over 97, or just simply, you can just simply write this one. So this is 2 and 30 over 97. So that is how we do this item. Question, clarification for that one.
None.
Okay. So next, number, I think we're on number 13. Okay. Number 13, surface. This is just simply a surface area. So surface area, cuboid. When we say cuboid, I assume this is a rectangular prism. So what am I going to do here is to divide this into two. So 1580 divided by 2 is 790. So in that case, 790 is actually equivalent to 20 times 14 plus 20 times the height, which is we don't know that one, plus 14 times the height. Okay, so 20 times 14, what is 20 times 14? That is 280. So 790 minus 280, so that will become 510. So 510 is equivalent to 20h plus 14h. So this is with the use of algebra. So we can just simply solve for the value of h here, and you are familiar with that one. So we divide now 510 by 34. H now will be equivalent to 15 centimeters. Question for number 13.
None.
Okay. Now, for number 14, this is how we do number 14, no? Um,
Oh, wait. 13? 13.
yeah,
Wait, it's a bit confusing now.
what? In number 13?
Yeah.
What part is confusing in number 13?
Like, how do I say this? 96. Maybe because I just didn't really look at it. Wait, can you let's stay like that?
Again.
Let me try to think about it again. Just don't erase it.
Ah, okay,
Thinking.
sige.
Okay, never mind. It's
Okay.
okay.
Number 14. So for number 14, what you're going to do here is first identify the prime factorization of 480. So there are many ways on how to do that one. So I'm not going to explain that kasi I know naman you know that one. So 480 is actually equivalent to 2 raised to 5. 2 raised to 5 times 3 raised to 1 times 5 raised to 1, correct? Now, how do we identify the sum of all the factors? So, for us to identify the sum of all the factors, this is how are we going to do it. This how are we going to do it. 2 raised to 5, this is the way you write it. We will start from 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3 plus 2 raised to 4 plus 2 raised to 5. Before I proceed, question.
None.
Next, for number 3, this is 3 raised to 1. So we will start with 3 raised to 0 plus 3 raised to 1. That's it. That's it for number 3. Question.
None.
And then for the last one, for the number 5, that will be 5 raised to 0 plus 5 raised to 1. So the next thing to do is just simply solve for this. 2 raised to 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is 16. 2 raised to 5 is 32. While for this one, this is just simply 1 plus 3. And then the other one, this is 1 plus 5. And then solve for the sum for each parenthesis. So this is 1 plus 2 plus, again, 1 plus 2 plus 4 plus 8 plus 16 plus 32. That is 63. 63 times 1 plus 3 is 4 times 1 plus 5 is 6. So multiplying this one, 63 times 4 times 6, and we will get 1,512. Question?
None.
So the process is clear naman, no? Sige. So I'm going to erase this one now. Let's move on to number 15. For the number 15 inside the sequence, 10, 20, 30, 40, 50, 60, so and so on and so forth. What is the 55th number? So actually, in this case, you can just simply, what do you call this? List down the numbers. Kasi if you write 10, let's say 10, 20, 30, I'll just skip writing 0. 40, 50, 60, 70, 80, 90, 100. And then the next, I'll write the zeros now so that will not be confused. Uh, okay. And then 110, um, 120, 130, 140, 150. So personally, this is the one that I'm going to do this one because this is less stressful. No need to memorize formula. 180, 190, and then 200. So let us count how many digits are there. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 21. So there are, this is the 21st number. 21st number. So this is 21, 22, 23, 24, 24, 27. This is the 30th. And then 33rd, 36th. And then 39th, 42nd, 45th. Oh, malapit na tayo. 45th, 48th, and then this will be the 51st. 51st, and then 210. 54th. right? And then 220. So the 55th number is actually this one. So that's how. Yeah. I think that's not confusing. Agree?
Yeah.
Okay. So let us move on to number. Let us skip first number 16 and 17 now. Okay. So let us skip that one first. So let us move on first to number 18. For number 18, I don't think that I need to explain number 18 kasi we can do that one manually. Okay, so for number 18, we can do that one manually. Tama? So you can just simply multiply 3. Yes, it will take time, pero this one is done. Yeah, you can do it manually. So no need to explain for that item. Let me now explain item number 19. So how do we do item number 19? Okay. So for item number 19, this is the trick here, no? So what are we going to do here is to multiply this by 4. So you need to what do you call this? Wait lang ah. Okay. So looking at this one, look at the difference. Look at the difference between the denominators. 1 and 5, the difference is 4. 5 and 9, the difference is 4. 9 and 13, the difference is 4. 97 and 101, the difference is 4. So in that case, this will be equal to 1/4 times. What's the first number here? The first number here is actually this one. 1 over 1. That's the first number. 1 over 1 minus the last number. And what is the last number? The last number here is actually 1 over 101. So this is the fastest way in doing this type of problem. This is actually this item is also the same with the mock test last time. So I'm going to explain that one also. So that's how we do it. Determine the difference between the denominators. If you see that they are all constant, then your denominator will be, you reciprocate that difference. So doon nanggaling yung 1/4. And then multiply it with the difference of the first number and the last number. Okay, so doing this, so we will now have 1/4 times 100 over 101. So solving for this, we will get here 25 over 101. Question for number 19.
Yeah, can you explain it again? I'm confused.
Okay, first, get the difference. 5 minus 1, 4. 9 minus 5, 4. 13 minus 9, 4. 101 minus 97, 4. It's constant. So reciprocate that
Yeah.
difference. That will be 1/4 times, get the first number. The first number is not this one. The first number is actually 1 over 1. So 1 over 1 minus the last number. The last number is this one. 1 over 101. So subtracting the two fractions, 1/4 times 1 minus 1 over 101. That is actually equivalent to 100 over 101. And multiplying those two numbers, and we will get 25 over 101. So that's it. That's how we do number 9. This is 101. Yan.
Mm,
Okay.
okay.
I'm going to clear this one na, no?
Yeah.
Okay. Next, number 20. Okay, so for number 20, this is how are we going to tackle this number. Um, we're asking for the value of those, right? So we're going to use the formula for grade 10. So what we're going to do here is to get the first term. The first term here is this one. This is the first term. And then the last term is this one, correct? So what we're going to do is to multiply, we're going to use this formula. First term, first term, first, first times, okay, multiply it by the last term minus 1. Last term minus 1 all over. Your denominator now will be, look at this one. What, for us to identify the next term, di ba we are just simply multiplying by 3. 3 squared times 3, it will be 3 cubed. 3 cubed times 3 raised to 4, that will be 3. Is that clear?
Yeah.
So first term times the last term minus 1 over their common ratio minus 1. So in this case, we can now substitute. The first term is 3, so that will be 3 times the last term is 3 raised to 11, or this number. 3 raised to 11 is 177,147 minus 1 divided by 3 minus 1 is 2. Continue. This will be simply 3 times 177,146 divided by 2. Then in this case, you can just simply, don't be careless about this one. So what we do here is we divide 177,146 by 2 and then multiply it by 3, and we will get the answer. So the final answer now here will be 265,719. So that is the process. How are we going to do number 20? Question?
Yeah.
Okay. Clear? Next number. Okay, what happened? 21. So the digit sum of 1,886 is 23. Find the number 4-digit number less than 2,000 with a digit sum of 23. So less than 2,000. 4-digit number less than 2,000. So it means that we are asked, so it means that the first digit is always 1, correct? Do you agree with that one, that the first digit is 1? Kasi it says here, a 4-digit number less than 2,000. So the first digit cannot be 2, correct?
Yeah.
Okay. Now, 1 plus the second number plus the second number plus the second number is equal to 23. Sir, why 23? Because we're asking, that's the question. Okay, 23. If we remove the first digit, it means that the sum of the remaining digits is 22. So, how are we going to identify how many combinations are there that when you add this 3 digits, the sum is 22? By listing method. First, you start with 9 and then followed by 9. Basta you always start with the biggest number. 9 and 9. So definitely this will be 4. 9 plus 9 plus 4 is 23. Next, we can still use 9. 9, then the next number is 8. So the last number will be 5. When you add those three numbers, the sum is 23. 9, after 8, we can use 7. And then here, it will be 6. So if you add those three numbers, you will get 23. We cannot write 9 and then 6 here. Why? 9 and 6 are already together on the third set. So we cannot use 9. Kasi if we will use 9, 6, and then this will be 7, these two are just the same. These two are just the same. So we will not do that one anymore. So for the first number that is 9, we're clear with that one. We'll move on to 8. 8, syempre we cannot use 9 here, ah. We cannot use 9 simply because we already written that one.
Wait, why can't you do 967 again?
We cannot go 967 because that's just the same with this one.
Yeah, but
967.
just ask. It's just yeah, but they're different numbers.
Yes, they are different numbers. Pero what are we doing here is that we are finding the combination of numbers. We are not yet identifying what are those numbers. We are identifying the
Hmm.
combination of numbers. It means that 976 can be arranged into 976, 967, 7 796, and then 769, and then 697, and 679. So that's what I mean with those three numbers. We are identifying the combination. We are not identifying the numbers yet. So that is the reason why we cannot use 967 muna. Question? Clarifications?
None.
Okay, so let us continue. So we're done with number 9s. Let's move on to number 8. So let me remove those muna. Okay. So number 8, 8. We cannot use 9 here kasi we already wrote it here. So 8, 8, and then this will be 6. And then 8, 7, 7. And then no more. We cannot write 8, 6, blank. We already wrote it here. Got it? Okay, let's move
Yeah.
on. Okay, so we're done with number 8s. Let's move on to number, can we use 7? Let's try. If we will use 7, definitely we cannot use 7, 8. If we use 7, 8, we already wrote that one. Can we use 7, 9? No, we already wrote 9, 7. Can we use 7, 7? No, because we already wrote 7, 7 here. Can we write 7, 6? No, because 7, 6 is already here. Sir, can we use 7, 5? No, we cannot. 7 plus 5 is 10. And 10 plus, for us to identify, for us to get 22, we need to add 10. And 10 is not a single digit number. So we cannot use 7, 5. So in that case, these are all the possible combinations. Okay? Now, let us count. How do we count now the number of combinations here? So if there are, if all the digits are different, we can use factorial. In that case, on the second row, all the digits are different. So in that case, this is 3 factorial. So that is 6. On the third row, all of them are different. So this is also 3 factorial. So this is also 6. The first row, the fourth row, and the fifth term or fifth row, um, there are digits that, what do you call this? That repeated. So if that is the case, what we're going to do here is that we will also write 3 factorial, and then we divide it by the digits that repeated. The digits that repeated here, how many times did they repeat? They repeat 2 times. So we divide it by 2 factorial. So in that case, that is 6 divided by 2, and that would be 3. Same thing with the fourth row. Same thing with the last row. The last step is to add these 5 numbers. So if you add those 5 numbers, the answer will be 21. Sige. Question first.
None.
Okay, so clear. Next
Wait. Can you go back again? Wait,
yan.
yeah, wait. Can I look at it for a while?
Okay, okay.
Wait, how 21 again?
Again. Inform me if you're done na.
Sir?
Yes, what?
In 886 and 887, why is it a 3?
6 and
886 and 887, why is it a 3?
886 and
Why are
88
they 3?
and 877, they are just the same with 994. Since a digit repeated,
Oh,
therefore we need to divide 6 by 2.
oh, oh,
Okay?
oh.
Okay, so we're going to move on to number 22. Okay. Now, for number 22, this is how we do number 22. There are 9 different pairs of chopsticks, meaning there are 18 chopsticks, correct? And then we're going to take 5 of them. How many combinations are there that none of them will be on the same pair? So in that case, we will now have here 5 fractions. So since we're going to take 5 out of them, we will start here 5, 4, 3, 2, 1. And then we will just simply multiply these fractions. What will be the numerators here? How are we going to identify the numerators? First, how many chopsticks are there? There are 18 chopsticks, correct? So on the first fraction, we will write 18. For the second one, since none of them will be the same pair, what we're going to do here is 18 minus 2, and that would be 16. Wait, sir, why 16? Why not 17? Or what's the reason why we put 16 there? If we have pairs of chopsticks, say for example, AA, and then we have BB, CC, DD, and so on and so forth. If we pick the first chopstick letter A, can we pick the second chopsticks as letter A? We cannot, correct? So how many remaining chopsticks are still available for picking up? There are only 16 remaining chopsticks. So that's the reason why I put 16 here. For the next number, same process. We will just simply remove 2 chopsticks. So this will be 14.
Well,
And
I
then
don't understand the question.
the question here is that, di ba there are 18 chopsticks, correct?
Uh-huh.
And then out of those 18 chopsticks, we will get 5, correct?
I thought 5 pairs.
Yeah, it's not 5 pairs. We will just simply take
Yeah,
5 chopsticks.
yeah.
Okay? And then the question here is that how many ways can be done if the 5 chopsticks are not paired up to each other. So it means that the chopsticks, their partners are not among those 5 chosen chopsticks.
Yeah.
Okay? Now, the numbers on our numerator. Any questions before I proceed?
None.
Okay? So the next number here, this will be 12 kasi we are just simply subtracting by 2. And then the last one will be 10. So you can just simply cancel out. Before you multiply, it's better to cancel some numbers.
Oh
So
wait, I'm sorry. I'm so confused with this. Why don't do certain numbers again?
we are subtracting 2 numbers simply because if the, what is this? Say for example, we have 9 pairs of chopsticks, A, B, B, D, D, and then E, E, and then FF, HH, II. So these are the 9 pairs of chopsticks. If in the first pick you got A, definitely on the second pick you should not get A, correct?
Yeah.
So how many remaining chopsticks are there? There are 16. That's why we got 16 here. Now, what if on your second pick you choose F or you got F? Definitely, you cannot choose letter F. So how many remaining chopsticks? One, two, one pair, two pairs, three, four, five, six, 7 pairs, and that is 14. So as you can see here, as the pattern goes, we are subtracting by 2. So that is why the numbers on top, we started by 18 and then we subtract 2 from 18 until we reach 10.
Yeah.
Now, syempre when we multiply numbers, we don't multiply it as it is. We can cancel out some numbers so that it would be easy. Say for example, 4 and 3, we can cancel out 12. 10 and 5, this would be 2. And then 2 and 9, 18, that would be 9. So that is 9 times 16 times 14 times 2, and this is manageable, and I think you can just simply do this, even though I won't reveal the answer na kasi you can easily identify the answer here, correct? O sige, for the sake, that's easy naman. 9 times 16 times 14 times 2, and we will get 4,032. So that's how we do number 22.
Yeah.
Okay, next number, um we are now on number, wait lang ah. We are now on number 23 na. I'm looking at my solutions. Okay, so number 23. This is somehow ano, pero let me try my best to explain this properly. 23, and then let's skip number 24. We'll move on to number 25 na. Number 23, find the value of that one. Okay. So, looking at this one, um oh my god, this is somehow ano, um is it okay if I'm just going to give the solution, um I'm just going to give the solution to your mom kasi this one will take time to ano, or you want me to explain this? Kasi this one is a bit long solution. What do you want? Give the solution? I already written the solution. Or you want me to ano, to explain this one?
Um. Sure. Can you explain?
Again.
Can you explain?
Okay, sige. Let me use a clean part here na. Hmm. Sige. First is to uh get first. So we will use two formulas here. First, the first thing is we get the last term. Last term, what's the last term here? That is 259. The last term is 259. Okay, so this is the last term, letter L. The first term is 25. So that is F. And then the common difference, that is D. How do we get letter D? Look at the numbers. Second term, 38. First term, 25. The answer is 13. How about another one? Let's say the third term. The third term is 51 minus 38. The answer is 13. So meaning it's constant. It's just the same. We keep on adding 13 on each number. So in that case, the common difference is 13. Before I proceed, question?
No.
Okay, so we need to identify how many numbers are in this sequence. 25, 38, 51, up to 259. How many are there? So in this case, what we're going to do is to use the formula. The last term minus the first term plus the common difference divided by the common difference. So the last term here is 259. The first term is 25 plus the common difference is 13 divided by 13. Before I proceed, question.
Mm,
So if we solve this one, the answer will be 19. Therefore, from 25 up to 259, there are 19 terms. Question.
no.
Okay. Next. Now, this is now the formula. So, clear? So, 19 ha. Remember, 19. So, to get the answer, this is what we're going to do. So, the first term. So, this is the formula. First term times the number of terms. In this case, that is 19. 19, we got it a while ago. Times the last term, which is 259. Plus, so the common difference squared. So the common difference is 13. So we need to square that one times the total number of terms, that is 19, times n minus 1. So 19 minus 1. And then times 2n minus 1. So that is 2 times 19 minus 1 divided by 6. Before I solve for this question.
No.
Okay, so the thing here is that you just simply need to be familiarized with this formula. So the first term is 25 times 19 times the last term, which is 259, plus the common difference. The common difference is 13. 13 squared times 19 times 18 times 35. Sir, where did you get 35? 2 times why 35? 2 times 19 is 38 minus 1 is 37. So it's 37 pala. Over 6. Question before I proceed.
No.
25 times 19 times 259. So that is 100. Yeah, you'll really get a big number here. 123,000 25 plus the one inside the parenthesis. So that is 13 squared, which is 169 times 19 times 18 times 37 divided by 6. So that will be 356 356,421, and then add those two numbers. So 123,025. So the answer is 479,446. Ayan. So clear? Let's move on. 24, let's skip that one muna so that ano. Let's move on to the last one. Okay. So the figure below is formed by three cylinders. From the top, view, the base of the radii of these cylinders are 5, 7, and 10 centimeters. The height is 5 centimeters, 6 centimeters, and 7 centimeters respectively. Find the surface area of this figure. Okay, first, let us identify the surface area of the top cylinder. So for us to identify the surface area is actually SA top. Okay, SA top. That's letter T. SA top is actually equivalent to, so the formula is 2 pi RH, 2 pi RH plus pi r squared. Pi r squared. Okay, so in that case, the surface area for the top one is 2 times the, it says here that pi is equal to 3, no? So approximation lang, 2 times 3 times the radius, which is 5. The radius is 5. The height is 5. The height is 5 plus 3 times the radius, which is also 5. And then squared. So doing this one, we will get here 150 plus 75, and in that case that is 225. So that is the surface area of the top. Next, surface area of the middle. Surface area middle. So since surface area middle, the one, this part is being covered. So something is covered on the middle cylinder. So in that case, we will get the surface area of the middle cylinder. So again, that is 2 pi r h plus pi r squared minus the surface area of the top cylinder, which is 225. So in that case, this will be now 2 pi RH. So 2 times 3. And then the radius of the middle is 7. The height is 10. Plus 3 times the radius of the middle one is 7 squared minus 225. Okay, solving for this one. This is 70 times 6. This is 420 plus 147 plus 147 minus 70. Ah, why minus 75? That is minus, it should be minus, wait lang. Oh, sorry. This is not 225. This must be, wait lang ah. This must be, okay. So, that must be the area of the circle on top. The area of the circle on top. And that is only 75. Kasi the area, the circle here is actually covering the middle cylinder. So, this is 75. And then this is also 75. Solving for this one. So this will be, wait nga lang. Wait. So, oh, sorry, this is 6 pala. Sorry, this is 6. Okay, so this is 42 times 6. So that is 252. Sorry for that one. So this is 252. So 252 plus 147. So 252 plus 147 minus 75. So that is 324. And then let's now get the surface area of the bottom. So surface area bottom. So same process. This will be 2 pi r h plus pi r squared minus the circle here. This one now, wait lang, I'll erase this circle on top. So this circle, that circle. So we need to get that area. So the area of that circle is actually 147. So this one. So minus 147. So let us solve here. 2 times 3. The radius of the bottom is 10. And then the height is 7 plus 3. R is 10. Okay. 3. Wait lang. Hmm, wait. Why is it 600? Oh yeah. 3 pi r. So that is 3 times the radius. The radius is 10 squared. This must be also multiplied by 2. Sir, but why 2? Because there is the bottom circle. So we need to also get that area. So minus 147. So in this case, this is 2 times 3 times 70. That is 420 plus 600 minus 147. So solving for that one, 420 plus 600 minus 147. So that is 873. So to get the total surface area, we will now add these three. 873, 225, and 324. So 225 plus 324 plus 873, and that will be 1,422. Okay. Now, let me just explain the items that I did not explain last time. Okay? So let me share another one. Though I gave the solution to your mom, but your mom wants me to explain those items. So for number 7 muna tayo. Number number 7. This one. This is actually the same with the one a while ago. So what we need to do is to get the difference. We get the difference of the denominators. 4 minus 2 is 2, 6 minus 4 is 2, 2016 minus 2014 is 2, 2018 minus 2016 is 2. Get the reciprocal of that one, that is 1 half. Multiply with the first number. The first number is 1 half. And then the second number is, or the last number is this one, 1 over 2018. So in this case, what will be the answer here? If we solve this one, I think naman you can try this one later. You can practice this one. You can use this one as a practice. So we will get 252 over
Wait,
1,000.
like, right? There's one half. Why is it the one half? This like does it change sometimes? The one half.
One half, one half came from the difference of this. 4 minus 2 is 2. 6 minus 4
Oh,
is
okay.
2. And then reciprocal.
Hmm.
And then this one half, the one half inside is the first number.
Yeah.
Okay? So solving for this will be 252. Okay. Got it?
Yes, I.
Next one. Number, wait, what number is this? Oh, number 8. Let's move on to number 8. I did not explain this one last time. So for number 8, this one, oh wait this one can be written as like this. So this one can be written as, look at my cursor ha. So this can be written as 66 times 65 minus 65 times 64, and then plus 64 times 63 minus 63 times 62 plus, and then this can be written as 4 times 3 minus 3 times 2, oops, times 2, and then plus 1 times 2. Agree? So I just put some parentheses here. Next, on this item, this one, we can factor out 65 here. So this can be now 65 times, the numbers remaining is 66 minus 64 plus, in here 63 is common to them. So we can factor out 63. 63 times 64 minus 62 plus, in here common to them is 3. So we can factor out 3. 3 times 4 minus 2 plus 1 times 2. You will notice that all of them, everything inside the parentheses will become 2. 66 minus 64 is 2. Um, 64 minus 62 is 2. Okay. Now, all of them has 2. So we can factor out 2. Then 2 times 65 plus 63 plus, and 65, sorry. 65 plus 63. Actually, these are all prime numbers. Odd numbers. Plus 3 plus 1. So how many odd numbers are there from 1 to 65? There are 33 odd numbers. If we want to identify the sum of the first odd numbers, we will just simply square the number of odd numbers. Since there are 33 odd numbers, so the sum from 1, 3, 5 up to 65 is actually 33 raised to 2, or 33 squared. So 2 times 33 squared, if we will solve for this one, we will get 2,170. So this will be now the answer for number 8.
Okay.
Number
Wait, 30 squared? Why 30 squared again?
again.
Why is 33 squared again?
Y is 33. There are 33 odd numbers from 1 to 65, correct? Now, why is it squared? That is the formula if we want to get the sum of the odd numbers.
Okay.
Okay. Next is number 17. Oh wait. There's number 17. Yan, this one. This is number 17. A rectangle is cut into 4 rectangles. If the area of it is 252 cm squared, how many cm at most does the perimeter increase in centimeters after cutting the rectangle? If the rectangle is being cut, therefore the perimeter will increase. So the thing here is that let us make the length as big as possible. So how do we do that one? If the area is 252, so what we do here is, what do you call this? 252. Um, what I mean is that let us make the length or the width as small as possible. 252. When we say 252, this can be, if the area is 252, then the dimension can be 252 by 1. It can also be 126 by 2. Between these two, we can choose the first dimension. But if we divide this into 4, then we will have a decimal number. Okay? So since we don't want a decimal number, we will focus on the second dimension. So if we divide the rectangle, so if you will see here, if we divide a rectangle, okay, so if this is the rectangle, let's say that's the rectangle. So if we divide that into 4 equal parts, so we divide it like this. We divide it somewhere here, and also we will divide it here. So assuming that is 4 equal parts. Okay, so assuming that is 4 equal parts, no? Now, if this is 126 and then this is 2, therefore the rectangle now is, this is the measurement of this is 1 and then the measurement of this is 61. Yeah, the measurement of this is 60, 126 divided 63 pala. Yeah, 63. Okay? Now, let's now compute the perimeter. The perimeter of the original rectangle is actually 126 plus 2 times 2, that is 256. Now, let's get the perimeter of the small rectangles. 63 plus 1, that is 64, times 2, that is 128. Kaso, there are 4 rectangles. So what will be the perimeter of those 4 rectangles? That would be 128 times 4, and that would be 512. How much did it increase? Just simply subtract these two. 512 minus 256, and that would be 256. So the answer for number 17 is 256.
Mm.
Okay?
Yeah.
Next one. Last two.
Okay, these ones I'm not really confused on, but I got it right. It's just my mom.
Okay. Number 19. For number 19, find the minimum value of the perimeter in centimeters. So in here, you just need to get the prime factors of 1001. The prime factors of 1001 is 7 times 11 times 13. So we need to create two combinations here. So if the area is 1001, okay, if the area is 1001, therefore the dimensions can be 77 times 13. It can be 91 times 11, or it can be 143 times 7. Let's get the perimeter. If the dimension is 77 by 13, the the perimeter now will be equivalent to 77 plus 13 times 2, and that is 180. Okay? Now, for the second one, 91 and 11, if we will get the perimeter, it will be 204. For the third combination, if you will do that, if we will get the perimeter, we will get 300. It is very obvious that this will be the focus of our answer. Why? Because we are actually looking for the minimum value of the perimeter. So what will be the answer? Since the length of each side is 2 centimeters, we will just simply multiply 180 by 2 centimeters. So 180 times 2 centimeters is actually 360 centimeters. So this will be now our answer. And number 24, the last one. Number 24, ito. How we do number 24. So I saw a solution in the internet. So this is how they must do it. So since the difference is 901, we split the numbers into 901, whatever the difference, we subtract it by 1. 901 minus 1, that is 900, correct? So we group the numbers by 900s. So the first group is 1 to 900. The second group is 901 up to 1,800. And then the next group will be 1,801 up to 2018 lang. Now, let us count the numbers from the first group and the last group. Let's count them. On the first group, how many numbers are there? So on the first group, there are 900 numbers. The middle group, disregard the middle group. The last group, how many numbers are there on the last group? So that is 2018 minus 1,801 plus 1. So there are 200. So in this case, there are 218 numbers. So we already got the numbers from the first group and the last group. What we need to do here is just simply add those two numbers. 900 plus 218 plus 1. It means that we will get only one number from the middle group. We only get one number from the middle group. So adding those three numbers and we will get 119 numbers. So at least 119 numbers to ensure, okay, to ensure a difference of 901. So that's those are the items that I did not discuss last time. Okay? So again, this is recorded naman. So I'm just going to send it na lang later kasi I'm it will take time to save this file on my laptop, okay? So any more questions or clarifications?
Wait. By difference of 901, it's like two numbers that have a difference
Yes.
of 901.
Yes, correct. The difference of see it says it's saying that what is the list number so that we can ensure that among those numbers we can pick two numbers that when you subtract those two numbers the difference is 901.
Also, like any number
Yes, correct.
to ensure, like if you pick any number.
Yes, if you pick any number. So at least you must pick 1,119 numbers to ensure so that you will be really sure that among those numbers there are two numbers that when you subtract you will get a difference of 901. Kasi
Yeah, but
you might think I can get two. If you get two, you are not sure that those two numbers can have a difference of 901.
like how
Okay.
um
Say for example, if you pick the numbers from the first group and the last group, these are the groups 1 to 900, right? From 1 to 900, any two numbers there, there's no difference of 901, correct? Kasi the biggest number is 900, the smallest number is 1. If you subtract that one, that is not 901, correct? Now, on the last group, the largest number is 2018, the smallest is 1,801. Therefore, 2018 minus 1,801, that is not 901, correct? But choosing those two and then picking any number from this group, any number, any number from this group, you can now ensure that there is at least one pair that when you subtract, the difference is 901. Example, you are holding now the numbers from 1 to 900 and the numbers from 1,801 to 2018. You are already holding them. If you pick any number between the second group, let's say you choose 1,500. 1,500, you can subtract 1,500 by 599. 1,500 minus 599, the answer is 901. So that's what we mean by this question. What is the least number of what's the least number that you must get to ensure that among those two numbers, there is what I mean is among those numbers there are two numbers that when you subtract, the answer is 901.
Yeah, but what about, let's say, 1 and 902 and 2 and 1 903?
Oh, 1 and 902, correct? You're saying that if you pick, so how many numbers you must pick to get 1 and 902?
Oh, but they're random, so you're not sure you're
Yes,
getting.
correct. You got it. You got it. They're random. You may say 2 but you are not sure that you will pick 902 and 1. Correct? So as long as you encounter this problem, this is the parang if I may say quote unquote formula in doing this one.
Okay, thank you.
Okay? So don't worry, this is recorded naman so you can go back to this one later. No?
You sure done?
Yes, we're done. Kasi I've explained the items that I did not explain last time. Okay?
Okay. Thank
Okay
you.
ba?
Bye.
Okay, bye.